Good afternoon. Last week we discussed probability. Part 2. Finish it. Let's start. Okay. Session number 5. Normal distribution. Okay. That is also part of the probability, but it is a one type of the probability distribution. Okay. Then these are the learning outcomes. Okay. Then we move into the lesson. Now you know the probability. Okay. Then we discuss the random variable. Then variable means what? Second lesson we discuss. Variable means what? Any measurable characteristic. We call that the variable. Okay. Then in here we identify the random variable. Okay. In the probability lesson we discussed the random experiment. Remember? Random experiment means what? Probability lesson is discussed that. What is a random experiment? Random experiment is a one kind of experiment. Okay, then you doing the experiment. Okay, then we identify possible outcomes. Okay, then through this random experiment. Okay, in the random experiment, we know all the possible outcomes. Okay, but we do not know which outcome now we can get. That we called as a random experiment. Then tossing a coin is a random experiment. Why? Then we know what are the possible outcomes of that random experiment. What are the possible outcomes? Head or tail. But we cannot say which outcome now we can get. We cannot say no. We can get head or tail. Okay, then definitely we cannot say now we can get the head. Now we can get the tail. But in the random experiment, we can say what are all the possible outcomes. Okay, but we cannot say what can we now get. Understood? That we called as a random experiment. Okay, then through this random experiment, we can identify the random variable. Then think random experiment is a toss in a coin. Okay, that is a random experiment. Then we want to identify the random variable. Then think we want to then we toss the coin twice. That's the example. We get the example. We toss a coin twice. Then we need to identify what is a random variable in here. Then we want to identify how many heads we can get. How many heads we can get. That is our random variable. In the statistic, normally we denote that random variable is x, or say we can use a 1. Okay, then x means what now? What is our random variable in here? Number of heads we can get. Okay, then we can say it is number of heads. What is it? It is a random variable. Our random experiment is tossing a coin twice. Okay, it means we toss a coin 2 times. Okay, then what is our random variable in here? Number of heads we can. Okay, then it is a random variable. What is the random variable in here? Number of heads. Okay, then we can assign the numerical value to the x. X is a random variable. Okay, then we move to assign the numerical value to the x. In here, then we toss a coin at twice. Then what are the results we can get? What are the outcomes? Then both times we can get hit. Okay, then we can get both times we can get the tail. Okay, then what is other? Head and tail and tail and tail. These are the possible outcomes. All possible outcomes in this particular random experiment. Okay, tossing a coin twice. Okay, then what are the possible outcomes? Head, head, tail, tail, head and tail, tail and tail. Okay, then in here, how many heads in here? 2. Okay, then 2. In here, how many heads? 0. Here 1. Okay. Then what are the values of x? What are the numerical values? Can be assigned to the x. 0, 1, 2. Okay, then we assign the values. X, 0, 1. Now clear? The random experiment is tossing a coin twice, no? Okay, then what are the numerical values we can assign to x? 1, 0, 1, 2. Why? Then both times we cannot get the head. Maybe, no? Okay, then other way, we can get the head at one time. Other way, we can get the head at the both time. Understood? It's clear? Okay, then we can assign the values 0, 1, 2. Zero, 1, 2. Understood? Okay. Then we move into get the probability value of respective these experiments. Okay. Now you know the probability, no? Okay. Then probability means possibility, no? Okay. Then we want to calculate the probability value of corresponding these experiments. Okay. Then how to get that? We can use in the tree diagram. Okay. Then using the tree diagram. Then is the first attempt. We can get head to tail. Okay. Then tossing a coin at twice. No? Then they are the second attempt. Okay. Then what are the probability values in here? In here, what is the probability value? 0.5. Half now. Okay. Then first one, what is the x value in here? 0. It means number of heads is equal to 0. In which branch? Tail. Okay. There is no any head. No. Okay. Then what is the probability? Half into half. What is the value? 1/4. Then the 0. What is the probability value? 1/4. Okay. Then move into the x equal 1. It means only one head can be. Okay. Then in here only one head. Head, tail, tail, head. Okay. Head, tail, tail, tail. What are the two probability values in here? Here 1/4, here 1/4. Then what is the probability value when the x value is equal to what? 2/4. Okay, 2/4 means. Understood? Then now, when x equal to, what is the probability? X equal to means this one. What is the probability value? Again, 1/4. Okay, then that we call as the probability distribution. Okay, then first we identify the random experiment, then define the random variable. Okay, then we assign the numerical value to the random variable. Then we calculate the probability value to each random variable value. Then we can get the probability distribution. Okay, then probability distribution we can display using the table format. Okay, or graph. This. Understood? That we call as what? Probability distribution. Okay, the number of head. It is a discrete one or continuous? Random variable is a number of head. No, it is a discrete variable or continuous one. Discrete one. Why? There is a clearly separated values. 0, 1, 2. Understood? Then that is a discrete probability distribution. And then variable, there are two types of quantitative variables. Second chapter you study. Discrete or continuous. Discrete means the values assigned to the random variable, there is always have a clearly separated value, we call as the discrete variable. Okay, then in here, number of head is a discrete variable, then we call as this one is discrete probability distribution. Understood? Okay, then we draw the graph using this one. This axis we shows the probability values, this axis shows the value of the x. Okay, then what are the values of the x? 0, 1, 2. 0, 1. Okay, then in here we have the probability value. Then 1/4, half. Okay, then first one is 1/4, then half, 1. This one. Understood? Okay, then that we call as the probability density function. Okay, it's clear. Then that we call as the discrete probability distribution. Then our random variable is a discrete variable. Then that probability distribution we call as the discrete probability distribution. Okay, then how to develop the discrete probability distribution? First we identify the random variable, then we assign the numerical value to the random variable, then we calculate the probability value of each numerical value of the random variable. Okay, then we can construct the probability distribution. Understood? Okay, in the statistics subject, in the discrete, there are two types of discrete probability distribution, binomial and the Poisson. Binomial and the Poisson. But in your syllabus only you have to study the continuous probability distribution. Okay, then binomial and the Poisson are the two types of the discrete probability distribution. It's clear? Then our variable is a discrete one. That is always goes to the binomial or Poisson. Okay. Then other variable is a continuous. No? Continuous variable means there is a infinite number of gradation between two measures. That kind of variables we call as a continuous variable. Okay. Then height, weight. There is no, always we cannot get the clearly separated values. No. Then weight is a 50. Someone weight is a 50.12. Okay, there is a we can get the infinite number of gradation between two measurements. That kind of variables we call as continuous. Okay, in the continuous variable, then first we identify the x. No, what is our random variable? It's clear. Then we can assign the numerical value to the x. But in the continuous variable, we cannot get the clearly separated values. Okay, then in here, continuous random variable, we cannot get this kind of probability distribution. Why? There is always, we cannot get the clearly separated values. In the continuous one, we can get this kind of probability distribution curve. Understood? In here, discrete, we have always three unseparated values. Then we can draw separate 0, 1, 2. But in the continuous one, we can get the infinite number of gradation between two measurements. Okay, then we think the 50 and 51, we can get the any number in between 50 and 51. Okay, we cannot say exactly this is the value. Therefore, we draw that one. We can get the any value. Understood? Okay, that we call as the continuous probability distribution. Okay, then continuous probability distribution is the normal distribution. Okay, then we have the three probability distribution: binomial, Poisson, and the normal. Binomial and Poisson are the two types of discrete probability distribution. Normal distribution is a type of the continuous probability distribution. It's clear? Okay, then the important probability distribution is the normal distribution. Then the Poisson and the binomial. Okay, in the every further analysis, then the in the inferential part and something, then always we want to check the normality assumption. Our variables are normally distributed or not. Okay, then based on that, we want to select the what is the appropriate test to analyze this kind of data. Okay, then therefore we will study the normal distribution. Understood? It's clear. Okay, then first we identify what is our random variable. It's a discrete or continuous. Okay, then discrete, then we move into the binomial or Poisson. Then our variable is a continuous one. We move to normal distribution. It's clear? Okay, then we start. Then the first one says normal distribution is the most important in the specific continuous distribution. Okay, understood? That is a one kind of normal distribution. Continuous probability distribution. Then one reason for the importance of this distribution is that it usefully models or describes the distribution of the numerous random variables that arise in the practice. Okay, then most of the random variables always follow the normal distribution. Okay, understood? Then binomial and the Poisson, finally we can distribute it as the normal. Okay, then therefore we can say normal distribution is the important probability distribution. Understood? Then binomial and Poisson initially distributed as a binomial and the Poisson. Okay, then finally we can assign these two probability distributed to the normal. Understood? It's clear? Okay. The normal distribution is a probability function that describes how the values of the variable are distributed. Then other one is in the normal distribution is the symmetric one. What is the meaning of the symmetric? Symmetric means we move to the middle point, then we can have the two equal parts. That we call as symmetry. Okay, that is the meaning of the symmetry. Okay, then the normal distribution is a symmetric one. Okay, then cluster around the central peak and the probabilities for values further distributed equally in both directions. Okay, then we move into that. Okay, normal distribution curve. It's a symmetric one. It means it's the middle point to center. Okay, then this one says most of the observations cluster around the central peak. Then all the observations cluster around this central peak. Okay, then what happened? We have the two equal parts. Okay, now you know what is the total probability value? 1. Okay, in this normal distribution, then area under this curve represent the total probability. Understood? Then this is the curve now. Here is the curve. Then this curve, under the area of this curve, we call it as total probability. Then what is the area under this curve? What is the area? What is the area of under this curve now? 1. Why total probability represent area under this curve now? Okay. Total probability value display the area under this curve. Okay, then what is the area of this under this curve? Equal to 1. Why? Total probability represent in this area. Okay, then therefore, area under this curve is equal to 1. Then what is the area of this part? How much? 0.5. In here, 0.5. Okay, why? It's the symmetric one. This is the center point. Then 1 divided by 2. 0.5. 0.5. Understood? Okay. Okay. Then this curve we call as the density curve. Then a density curve is an idealized representation of the distribution in which the area under the curve is defined to be 1. Okay, then why the area under this curve is equal to 1? This area represents the total probability. Okay. Then this is the formula in here. We do not use this formula to get the value. Okay, you can use in the Z table to get the probability value. Okay. Then we move into what are the characteristics of the normal distribution. These are the characteristics of the normal distribution. What are the features of the normal distribution? Okay, then what is the first one? It is a bell shape. It's drawn up. It's drawn as a bell shape. Bell. Do you know about the bell? Okay. The bell shape curve and has the single peak. Okay. Only has the single peak. Okay. Then at the exact center of the distribution. Second one, it is a symmetric. Now you know that it is a symmetric one. About its mean. It means in the center point of the normal distribution is space is the center point. That center point represents the mean here. Okay, then median value. And the norm. These three are central tendency measures now. Mean, median, norm. Okay, in the normal distribution, the values of these three measurements are equal. Okay, mean, median, and the mode. Think mean is 20, then median is 20, mode is also 20. Okay, then mean, median, mode is equal in the normal distribution. It's clear? It's simple under this center point. Okay. It falls off smoothly in either direction from the central value. Okay. Smoothly. Falls off smoothly now in here. Okay. Then it is a asymptotic. That is the tails of the curve extended indefinitely in both directions, minus infinity to plus infinity. It means when we draw the curve, okay, this curve does not touch the x-axis. then we cannot draw this way. This is the normal. Okay, then these two tails do not touch this x-axis. Okay, remove this. Okay, understood? The curve does not touch the x-axis. Okay, it is go to minus infinity to plus infinity. Okay, understood? This is the normal distribution. Okay, that is the fourth point. The curve gets closer to the x-axis, but never actually touches it. Can be a curve. Okay, but cannot touch. Understood? These are the characteristics of the normal distribution. Okay, this is the bell-shaped curve and the symmetric. Okay, then middle point represent the mean. Then mean, median, mode are same in the normal distribution. Okay, then normal curve gets close to the x-axis but never touch. Okay, then probability of under the normal curve is equal to 1 by it is represent the total probability. Understood? Okay, it's clear. Then these are the characteristics of the normal distribution. Okay, and this one shows all the things. Okay, in here says no. Normal curve is a symmetrical one. Okay, then in here these points we called as a tail. These we called as a tail. Okay, then middle point represent the mean, median, mode. These three measurements are equal. Clear? Okay, then total probability is 1. Okay, then there are two equal parts. Then probability of the one part is 0.5. Okay, then the inflection point is x. In here, then we think x is the weight. X is a random. X always represent the random variable. Think random variable is weight. Weight is a continuous variable. Then in here, this point is average weight. Then think average weight is 55. It's the mean value. Okay. Then we put in here x value is equal to 60. Then this is the inflection. Okay. Then other special thing in here, in the discrete probability distribution, we can get the probability value of the x equal 1, x equal 0, x equal 2. We can get the previous example we discussed. Okay, then tossing a coin at twice. When x equals 0, probability value is half. When x equals 1, probability value is, first one is 1/4, second one is, when the x value is 1, our probability value is half. We can get the probability value when the x equals certain value. But in here, normal distribution curve, we cannot get the probability value when x equals 60. X equals 60, what is the probability value? 0. It's clear? We cannot calculate the probability value when the x equal constant. Okay, but we can calculate the probability value. Then x represents the weight. Then we want to identify what is the probability their weight is more than 60. More than 60 means this is more than 60. Then we calculate the probability. Okay, but we cannot calculate the probability when the x equals 60. Okay, then we can calculate the less than 30. We can calculate. Okay, then we can calculate weight is in between 30 and 60. This area we can calculate. But we cannot calculate the probability of the constant value. Probability of the x equals 30, x equals 60, we cannot calculate. Why? This is the density curve now. Okay, then always we can get the gradation between two measures. Okay, then in this way, in the normal distribution curve, we cannot get the probability value when the x equals constant value. Understood? We can get the range always. Greater than 60, less than 30, then in between 30 and 60, we can get. Understood? Okay. Okay. Then the 8 is our random variable. Okay, 8 is a continuous random variable x. Okay, then the mean value is equal to 55. Okay, in the normal distribution, there are two parameters in here. Okay, parameter. How to measure it? Okay, then in the normal distribution, in here there are two parameters, mean and the variance. What are the two parameters? Mean and the variance. Now you know the mean and the variance. Okay, mean and the variance. Then mean is 55. Then we calculate the variance value. Is 20. Okay, 50. It's clear? Then we need two parameters values, no? Mean and the variance. Okay, then we draw the normal distribution curve. Then this line shows x. Middle point represent the what? What represent the middle point? Mean value. What's the mean value? 55. Okay, then if we want to get the probability value, x is greater than 60. Okay, greater than, then we can under 60. We want to get the probability value where the x value is greater than 7. Okay, then in here, where is the 70? In this side. It's the same. Greater than 70 means is there. Okay, but we cannot calculate the probability value using the x values. Okay, then this x value we converted into the z. Okay, that we call as the standard normal distribution. What we call as standard normal distribution. This is the normal distribution. Okay, then when we need to calculate the probability value, first step is what? This x value we converted into the z value, we call as standard normal distribution. Then we draw the z line. Okay, in the standard normal distribution, always mean value is equal to 0 and the variance is equal to 1. Understood? The two parameters are mean and the variance. Okay, in the normal distribution, we can get the any value to the mean and the variance. But we converted into the standard normal distribution, always our mean value is 0, variance is equal to 1. Okay, then we want to get the z value to the corresponding this x value. What is our x value in here? 7. And then now we are looking at how to convert this x value to the z. Okay, then there is the function to calculate the z value. With the formula z equals x minus v divided by the standard deviation, not the variance. Variance is a parameter. It's true. But in this formula, we take the standard deviation. Okay? Then how to convert it now? X value is, what is the x value? 7. What is the mean value? 55. What is standard deviation? Then what is the standard deviation? Variance is 16. What is the standard deviation? 4. Square root of the variance. What is the standard deviation? What is that? 60 minus 55. 5. Then 5 divided by 4. 1.25. 1.25. Okay, then what is the value in here? 1.25. Okay, understood? Okay, and hang up next. Okay. Then using the table, we can get the probability value. Now we have the z value. What is our z value? What is our z value? 1.25. Okay. In your table, there are rows and columns. Okay. First column represents the first decimal place. Okay. This first row represents what? Second decimal place. Then we need to get the 1.25. Then find out 1.2. We find out the first column. Okay. The second decimal place is 5. Then 0.05 we found in the first row. Then what is the value here? 0.3944. That is the probability value. But this table always we get the probability value 0 to this one. Okay, then 0.3944. That is the probability value 0 to 1.2. It means this area. Okay, but we want to get the probability value of the greater than 1.25. Then how to calculate this area? 0.5 minus this one. Why? This area is 0.5 no? Up to that point 3944. Then how to get that area? 0.5 minus 0.394. What is the value? 1056. Understood? Okay. Then in this side same. Okay. Then we calculate the then 50. Then minus 1.25. Then we looking at the table, we get the probability value this way. Okay. Always read it 0 to this value. Okay. It's clear? Okay. Then this picture shows that one how to convert our x values to the z values. Okay, using this formula, we can convert it into the x into z. Okay, then we have the z value. We can use in the z table. We can get the z. Okay. Then this is the formula. Z equal x minus mu divided by the standard deviation. Then the question asks, what are the two parameters in the normal distribution? Mean and the variance. But in here formula, we want what? Standard deviation, not the variance. And the question says variance, then we take the square root of that. Okay, it's clear. In the formula, it mentioned the standard deviation, not the variance. Then all the things are explained. Okay, Z is a measure of the number of standard deviation of that data point from the mean. Then X is any point on the horizontal axis. X means numerical value of the random variable. Mu is mean, sigma means standard deviation. Okay. Then we do this exercise number 1. Hurry up. Then there is no anything. Then this question is give the all the z value. Okay. Then you want to find out the probability value. Okay. Then hurry up. No need to convert. Okay. Then the question is given the z value. Okay. Then using the z table, you want to find out the probability value. What is the answer for the part A? Less than 1.33, 0.5 minus 0.40. Less than 1.36 factor, 0.5 plus 0.4082. Then what is the answer for the part A? 0.9082. Okay. First one. Part B. Part B. If it is less than or equal minus 0.79. Okay. Then you know middle is 0 minus value in here. It's always shows the number line. Okay. Less than. Okay. Then what is the probability value? 0.79. 2852. 2852 gives this one. 0 to this one. Then how to do that? 0.5 minus 285. Zero point 2148. It's okay, no? See, that value will be between 0.55 and the 1.2. When both values are plus, okay, then in here 0.55, 1. Okay, then Z value is 1.22, 3.3886. Okay, then this one is 2 to 8. Then 0 to 1.22 is equal to 0.3888. Okay, then we looking at 0.55. 2088, it gives 0 to 0.5. Then how to get this value? Take this probability value, then find this value. It means 0.3888 minus 0.2088. What is the answer? 0.1800. Okay, part C. It's clear? Then moving to the D. Minus 1.90 and 0.44. One is the plus one, other one is negative one. Zero minus 1.90 plus 0.4. Okay, it's easy enough. Then we're looking at 0.44, 0.1700. It gives 0 to 0.44. Okay, then we're looking at the 1.90, 4713. Okay, then 4713. Understood? Then how to get the probability value? Add them together. What is that? 0.6413. Understood? Yeah. No. Plus or minus same probability value. The area, ignore the sign. Okay, then always give the 0 to 1.90. Then 0 to plus 1.90, same probability value. Okay. Always we get the area. Do not consider about the sum. Then part E, 0 to 1.5. Then this is the 0, then 1.5. It's very easy. Okay, then looking at the probability value for the 1.5, 0.4332. It's the probability. Its value is 0 to 1 point. Okay. Last one, probability is greater than or equal minus 1. Here, minus 1. Greater than. Okay. Then we looking at the one from the table 0.3413. Area, then we add the 0.5. And then 0.8413. Understood? Now clear how to find the probability value using the exact values. Okay, always read the table. Always we get the probability values 0 to particularly exact value. Okay. Then we move into the practical calculations. Okay, then first step is read the scenario, then identify what is our random variable in here. Okay, then we identify this random variable is distributed at which probability distribution. Okay, it may be a binomial, Poisson or no. In your syllabus or you have binomial. Okay, then the X is distributed as normally, then you find out what are the two parameters valuing here. What is the value of mu? What is the value of variance? Okay, then we switch to answer these questions. Okay, then these are the steps. Okay, first read the question. It's a very simple one. First read it. Here, what is the variable? Here, what is the variable? Variable. Not the value, the variable. I give 4. It's the variable. Okay, then first you identify what is the random variable in here. In here, what is the random variable? I give 4. Then first you write your random variable x. Okay, then what is the x? I give 4. It's 4. It's a random variable. Okay, then you find out what is the probability distribution. Okay, in here says normally distributed I give 4. Okay, then what is the probability distribution in here? Normal distribution. Then we write A is distributed. This is the sign to find the distributed. X distributed normally. The normally distribution we define as the capital. Okay, then X distributed normally. This is the sign of the normal distribution. Distribution කියන එක පෙන්නන sign එක තමයි. Okay. Then in here is the normal distribution. Okay. Then normal distribution have the two parameters. What are they? Mean and the variance. Okay. The next step is within bracket we have to mention the two parameters values. Okay. Then what is the mu and what is the variance? Okay. Then we write x distributed normally. In here, what is the mean value? 100. Then what is the variance? In here, what is the variance value? Yeah, 15 square. Okay, then you can write 15 square. Okay, always you want to find, then you can write 225 or you can write 15 square. Okay, then question is given the standard deviation, not the variance. But in here, what is the parameter? Variance. Okay. Then finish. Then move the question. What is the probability of randomly selecting someone with an IQ score that is less than 50? Okay. Then we write the what is asked from this question. Probability of IQ score is defined as the x number. X is less than 50. Less than x value less than 50. Okay, it's clear. Then using this information, you can draw the Newman distribution curve. Okay, then first axis represent x number, x values. Okay, then what is the middle point? What represents the middle point? Mean value. In here, what is the mean value? 100. Question asks, what is the x value in here? 50. Less than 50. Then we in here 50 is there. Okay. Then less than means. Okay. The next step is what? We want to convert it into the z values. Okay. Then we draw the line. What is the mean value of the z curve? 0. Then we need to get the value of the z value of the 50. How to convert it? Using the formula. X minus mu divided by the standard deviation. X is 50. Mu is 100 divided by 50. Okay, then this will change into the 70. This change into 70. 70. Then we cannot get the property value, it becomes the 0.5. Okay, 70. Then what is the z value in here? 70 minus 100 minus 30. Minus 30 divided by 15 minus 2. Then here z value is minus 2. Okay, then we looking at the table. What is the probability value? 2? 0.4772. This is the 0 to minus 2. Okay, 0.477. Okay, but we want to get this rate. How to get that? How to get the probability value? 0.5 minus 0.477. What is the probability value? 0.0228. Clear? Okay. Then go to the next part 2, greater than 7. Now we'll find out. No need to write these 3 lines again. Okay? The starting point, you have to write these 3. What is our random variable? What is the distribution? And what are the parameters in here? Okay? Then you write the questions. First one is okay. Now let's do the part. Second one, greater than 70. distribution are greater than 70. Greater than 70. Okay, then how to get the probability value? 0 to minus 2, this value 0.4772, then plus 0.5. Okay, then what's the answer? 0.977. Greater than 70. Okay. Then this area, keep the table, then we add the 0.5 from this. Okay, then try part 3. Okay. Between 75 and the 100. Okay. Between 75 and 100. Okay, then 100 is the mean value now. Then standard normal distribution, what's the Z value? 0. Then we need to get the value of the 75. What's the answer? 75 minus 100 divided by 15. 1.66. Answer. Then we write minus 1.67. Round off at 2 decimal places, then 1.67. What is the answer? 0.4525. Okay, clear? Then try question number 1. First identify what's the random variable, then write the distribution, then mention the parameters for it, then write the answer. The mean lifetime of the 16-watt bulbs produced by the company is 200 hours, and it is also known that the standard deviation is 20 hours. Assuming that the lifetimes of the bulbs are normally distributed. Find the probabilities that the single 60-watt bulb taken from the production lot will burn out at a time between 180 hours and 210 hours. Okay, then the first step, we want to define what is X. What is X? Lifetime of a bulb. Okay. Then this X is normally distributed. X is normally distributed. In brackets, we have to mention the two parameter value. Mean value is 200. Variance is 20 square. Okay, then we go with the answering the question. Between 180 to 210. Okay, 180 to 210. Then we draw the normal curve. The mean value is 200. The next value is 180 and the 210. In between is same. Okay, the next step is convert it into the Z values. Mean of the Z value is 0. Then what is the Z value in here and here? 180 minus 1, no? Then minus 1. This one is 0.5. Okay. Then we need to get the probability value in this area on the meter form. Then we can directly taken from this table. One is 0.3413. Then 0.5 is 0.1915. Then add them together. 1915 plus 0.341. Okay. In this question mark, the calculated probability value. Then some questions can be asked, calculate the percentage value. Okay, then how to convert this probability value to the percentage? Multiply by the 100. Then what is the percentage? 53.28%. Understood? This is the percentage. Then the question asks, calculate how many bulbs will burn out at this time range. How many bulbs? This is the probability value. This is the chance of the 1. Okay. Then how to get the how many bulbs will burn out in between 180 to 210? Take this probability value multiplied by the total number of bulbs in our production lot. Okay, then think we study the 1000 bulbs. Then we take this probability value. then multiply by the 1000. How many? 532.8. It means 533 times. Understood? This is the probability. This is the percentage value. This is the number of observation. It's clear? Okay. Then part 2 is okay. Greater than 230. Finish. Greater than 230. Then we convert this in here 1.5, no? 7 divided by 20, no? Then probability value is 0.4332. 0.4332. Okay, then we need to get the probability greater than 230. Then we say, then how to get that? 0.5 minus 0.4332. That is the answer. 0.0668. Understood? Okay. Okay. Then try question number 2. Question number 2. Question number 2. A statistical analysis of 1,000 telephone calls made from a large business office indicated that the length of these calls is normally distributed with mu 126.5 seconds and the sigma is 30 seconds. Sigma means standard deviation. Then what is the x in here? What is the x? Length of a call. Okay. Length of a telephone call. Okay. Then x is normally distributed. Then what is the mean value? 126.5 and variance is 30 square. Okay, then these are the information is given in the question. Part 1 asks, what percentage of these calls are less than 180 seconds? Its value is less than 180. Then this is 126.5 mu, then 180. Less than 180 means, okay. Then we want to convert it into the z. This is 0. Then what is the z value in here? 180 minus mu value 126.5 divided by 30. Okay. Then what is the answer? 4.5 divided by 30. Answer 1.8. 1.78. 1.78. Yeah, then looking at the table. 4625. Okay, then 0.4625. 0 to 1.78. Okay, then but we want to get the probability of this total area. This part is already 0.5. Okay, then what is the total probability value in here? 0.9625. Okay, then question asks calculate the percentage. What is the answer? 96.25%. Okay. Then part 2 asks how many calls lasted more than 60 seconds or less than 150 seconds. More than 60 and less than 150. And 150. Okay. Then we want to calculate the two z value in here first. What are the two z values? .78. Okay, then in here 2.21. 2.21. Okay, then looking at the table, we can directly get the two probability values by 0 to this value, 0 to this value. Okay, then add them together. What is the final answer? 0.78, 0.2823. Okay, then add 2.21, 0.4864. What is the answer? 0.7687. But question asks what? How many calls? Not the probability. Then how to calculate the how many calls? In survey, total number of telephone calls in here 1000. Then that value multiplied by the 1000. How many calls? 768.7. It means 769. Understood? Okay.